So number 5 of the implicit differentiation worksheet. Find dy dx and the second derivative given that y squared plus 2y equals 2x plus 1. So first derivative would be 2y dy dx plus 2 dy dx equals 2. That's a fairly straightforward one, right? There wasn't a product rule or a quotient rule. Pretty straightforward. Factor out all the 2's. I guess I'll get it later. At some point I'm going to get rid of all those 2's, but factor out the dy dx, and then divide by 2y plus 2, and then I'll reduce it to 1 over y plus 1. Okay with that? All right, now I need to do the derivative process again to get the second derivative. What rule do I need for that? Quotient, there is a sneaky way around the quotient rule. Yes, so I can do either one. I can do the quotient rule as it's written, or I can say, you know what, I don't like the quotient rule, I want to do power rule. But then it's a negative with the power rule, and so maybe that's complicated. So you got a preference? You want me to do quotient rule or power rule? Power rule, okay. So the second derivative then is bring down the negative 1, y plus 1 to the negative 2, times the derivative of y plus 1, which is dy dx. Now, I don't think that we want to leave it like that. I think we want to plug in what dy dx is. So the second derivative is, let's see, negative 1 over y plus 1 squared times 1 over y plus 1. So negative 1 over y plus 1 cubed. That's kind of odd, but so there's the second derivative, there's the first derivative. Number 7. Consider the curve defined by y plus cosine y equals x plus 1, where y is between 0 and 2 pi. Don't know really how that matters yet. Find dy dx in terms of y. So dy dx plus derivative of cosine is negative sine of y times dy dx equals 1. So we'll factor out dy dx. 1 minus sine of y equals 1. Divide by what was left. So 1 over 1 minus sine of y. Part B. Write an equation for each vertical tangent to the curve. Vertical tangent lines. What do vertical tangent lines look like? Show me with your arm. What does a vertical tangent line look like? Most of you like did this and then quick look around. Yeah, okay, good. Vertical tangent line. What's the slope of a vertical tangent line? undefined. So m equals undefined. The slope of a vertical tangent line comes from the derivative. How do I get a derivative to be undefined? What would make a derivative? What would make this thing be undefined? What can't you do? Can't have 0 on the bottom. So if denominator equals 0. So if my denominator of a derivative is 0, that would be an undefined slope. That would be a vertical line, so that's where our vertical tangent lines will be. So 1 minus sine of y equals 0. So sine of y equals 1. That happens when y is there. That'd be pi over 2. Now let's check and make sure we answer the question. Write an equation for each vertical tangent to the curve. What's the equation of a vertical tangent line look like? X equals. I've got y equals. So I need x equals something. So if I know what y is, how am I going to figure out what x is? Plug it in. Back in the original equation, we'll plug in pi over 2 for y to figure out what x is. Oh, I guess if I wanted to be, I don't know, not lazy, just safe maybe. If I'm worried about cosine of pi over 2, just move over the 1 and leave it like that. That's the equation of my vertical tangent line, because that's where y equals pi over 2, which makes the denominator of the derivative 0, which means we got an undefined slope, which is vertical. I guess if we wanted to clean that up, cosine of pi over 2 is 0. So pi over 2 minus 1, if we wanted to take care of the trig in there. Vertical tangent lines when the denominator of the derivative is 0, because that makes an undefined slope. Part C, find the second derivative. Start over here. So dy dx was 1 over 1 minus sine of y. All right, I let you pick last time. I'm going to pick this time. I'm going to do the quotient rule this time. But this is another one where you could avoid the quotient rule by doing 1 minus sine of y to the negative 1. F prime is 0. G prime is negative cosine y dy dx. So the second derivative is gf prime. Oh, that's kind of nice. What does gf prime become? 0 minus the other way around, negative cosine of y dy dx over g squared, 1 minus sine of y squared. And then for some cleanup work, the two negatives become positive. And dy dx, we know what that is, so we can plug that in. And I guess that'd be an okay place to stop. But since those are the same thing, 1 minus sine of y cubed. All right, good questions.